All right, so the other part of the complex numbers is what we call Argand diagram. Argand diagram, it is the complex numbers Cartesian plane. Remember, in mathematics, we've got what we call a Cartesian plane. Now, a Cartesian plane, it's this thing. This is what we call a Cartesian plane. Remember, this is your y-axis and this is your x-axis, but we're coming there. Now, with the Argand diagram, we need to remember that our real part is represented by A and our imaginary part is represented by B, the number that is attached to I. Now, as I've written there, that Argand diagram, it is the complex number Cartesian plane. Now, our x-axis represents the values of the real part, the number without I, and then, or rather without a variable, a constant. We can also write it or call it a constant. Let's call it a constant. And then y-axis, it is representing the imaginary part. Now, with the Cartesian plane, remember, we work with coordinates. Now, with coordinates, we have x and y. As we said, x and y. Now, in this sense, if our x-axis is represented by real part, it means our x will always be A. And then if y represents the imaginary part, our y will be B. Now, this is how we are expected to actually plot the values of A and B. This is your y-axis, which represents the imaginary part. This is the x-axis, which represents the real part. Now, if we are, for instance, given x is equals to A plus BI, our B will be somewhere there and our A will be somewhere there. And then we draw a vertical and a horizontal line. Where those lines connect, that is where the coordinates will be written. And then from here, we will then draw what we call a triangle. I can't hold up that ruler, so I'm just gonna do that. So this is the triangle that we are talking about. This is the complex Argand diagram. Now, with this, we realize that this is where the value of our real part is, and this is where our imaginary part is. Because let me explain why I wrote these. I wrote these two in the way that I wrote them so that you can see that the imaginary part is moving vertically and the real part is moving horizontally. But that is not where the real part is. The real part is the x-axis and the imaginary part is the y-axis. So this is our y and this is our x. We see. Now, with this right-angled triangle, remember we said that the opposite side to the 90 degrees is called hypotenuse. So this is our hypotenuse. We will talk about that. Our hypotenuse in complex numbers is called modulus, but we will get there on a later stage. Let's look into this example. They say to us, represent this complex number on an Argand diagram. What is the value of A? Remember, we must write it in the value of A is to B. Now, what is the value of A? The value of A will be -3 and the value of B will be +4. Now, let's go ahead and check where is these two on our Cartesian plane. Maybe we are given 1, 2, 3. Remember, this is a negative side of the x-axis. And then maybe we are given 1, 2, 3, 4. This is the positive side. Now, remember, we've got a -3 and a +4. We want to draw them vertically and horizontally. Let's start with 4. That is where our 4 will go. And then let's go ahead and meet our 3. That is where our 3 will go. And then where they meet, remember I said that is where you do what? You write your coordinates. -3 is to +4. And then you then draw your triangle. As simple as that. As simple as that. Now, we've got what we call a modulus. Now, what is a modulus? A modulus represents it represents the value of the hypotenuse. This is how we write our modulus. Now, our modulus, it will always be equal to the square root of a squared plus b squared. Let's check what's the value of our modulus in this sense. We will say the square root of the value of a is -3 squared plus the value of b, it's 4 squared. And then we will have the square root of 9 plus 16, which will be 25. It simply means that our modulus value will be 5 plus or negative. So it does not matter, but that is where the value of the modulus will be. Right, let's do the last example. Let's say that we are given m is equal to, let's say we are given m is equals to -3i minus 2. In this sense, the value of our a is equals to -2. The value of our b is equals to -3. Now, in other words, we will have -2 is to -3. We want to check where in the Cartesian plane will these two lie. Now, we come back here. Let's say that we have -1, -2, -3, -4. We come back here. We check where is our sorry, where is our -3? So this is where our -3 is. It goes with -2. There is our -2. Where they both meet, we write -2 is to -3 because those are our coordinates. And then we draw our modulus. And then this will be our right-angled triangle. This is where our modulus will be. I hope you understand. If you do not understand, please do contact me so that we can discuss all the things that I've explained on these 3 topics under complex numbers. We are not done, by the way.